Hello and welcome to another edition of Lost in Science across Australia on the Community Radio Network. A bit of a sad episode this week, commemorating the passing of Professor Stephen Hawking, probably one of the most well-known physicists ever, I would say.
Certainly one of the most famous scientists in the world, I would say.
I would say he's the most famous scientist in the world.
Yeah, take that, DeGrasse Tyson. But we are gonna talk a little bit about Stephen Hawking's work, and also a little bit about, I guess, one of the other iconic things about him was that he was confined to a wheelchair since he was in his 20s. And I was just going to talk a little bit about motor neuron disease. And Claire, what have you got for us this week?
Nerve gas has been in the news again over the past couple of weeks. There has been an attack recently in the UK. And so I thought I would uncover the science of nerve gas, what it is, how it affects the body, and this specific nerve gas that was used in this most recent attack on a former Russian spy. It's all about nerve gas today also.
What's the nerve gas called?
Novichok.
Is it Russian?
Yeah, it is.
It was used on a
Allegedly.
Russian spy.
Allegedly.
We're not pointing any fingers here, are we?
No, allegedly Russian.
We're not pointing any poison umbrella tips or anything either.
Well, it's also very topical because Putin just got back in.
I was going to say we're not Putin anything out there, really.
I don't even know if that's a pun.
No, I don't think it is.
Barely makes it. Anyway, on with the show.
Yes, you are listening to Lost in Science. My name is Chris, and we are all saddened by the death of Stephen Hawking at the age of 76. But I want to talk about the man, his work, what made
His
him...
legacy.
His legacy, what made him such a loved figure, I suppose, the popular face of science. Yeah, I guess.
Can I just ask, have you guys got any of his books?
Yes.
No.
Have you read any of his books?
I have.
Yeah?
Yeah, I'm not sure if I really understood A Brief History of Time, but I did read it.
That is the most famous one. And
Yeah.
that is pretty much, I think, the main source of his fame. It is one of the best-selling, if not the best-selling science books of all time. Although
The best-selling. But what do you think the percentage of actually read would be?
Well,
Doesn't matter.
That's the debated thing. No, I mean, I've read it. I will admit that I've read it, but then I am a physicist,
Yeah.
So
So you should have read it.
You should have read it, yeah.
Just as I've read Origin of the Species, because
Yes.
I'm a biologist.
Yes.
So.
But no, I read it while I was studying physics at the University of Queensland, and yes, it did make quite an impression on me. It's a really good overview leading up to the modern state of particle physics and cosmology, or at least as it stood in the late 80s when it was written. Many other books have covered similar ground to what that book covers, but not I guess not really. They're just kind of moving in Hawking's wake in that sense, Now, this fame, this was one of the things that led to him being regarded as one of the most brilliant minds in the world. He kind of fills that role in cameos on TV shows, like Star Trek Next Generation, The Simpsons, The Big Bang Theory. But yeah, Hawking was kind of regarded, I suppose, to the popular mind, regarded as sort of the next Einstein, which, look, let's be honest, this confused a lot of physicists because we thought, well, he wasn't really on the level of Einstein with his achievements. But look, let's face it though. I mean, if you were going to say someone is kind of close but not quite Einstein, that's a pretty good compliment anyway. Yeah. Anyway, but it's also not the point. It's also not the point, but I will get to what is the real point later on. But I want to talk about what he is famous for in terms of scientific achievements. And this is the thing he's most famous for is something called Hawking radiation. This is a theory he wrote down in 1974. And it is a radiation that is given off by, or believed to be given off by black holes.
Well, and yeah, so the whole basis of the idea of a black hole is that nothing can escape the gravity.
This is correct.
And so therefore what happens to all the stuff that goes into the black hole basically? Isn't that the question he was sort of pondering?
The actual way he went about it is quite complicated. Look, I'll explain what it is about. It's basically it is combining Einstein's general theory of relativity and quantum mechanics. And this was kind of a landmark achievement in combining the two because they are famously very difficult to unite. So Einstein's general theory of relativity, or general relativity for short, that is a theory of gravity that explains that gravity involves a curvature of space and time. So heavy masses like the Earth will bend space around them and also slow down time. And so when objects move through that curved space-time, they will move on a curved path. This effect is most noticeable when the gravity gets really very strong, so like near stars or on large scales, like the scale of galaxies or even the entire universe. Now, quantum mechanics, on the other hand, deals with like the other end of the telescope, things of an atomic level or smaller. So everything kind of gets fuzzy at that level. So, for instance, particles being at like kind of a random distribution of locations, sort of a fuzzy kind of cloud rather than a fixed kind of little point. And even a vacuum, like empty space, is not actually empty, but it's full of little pairs of particles and antiparticles popping in and out of existence on the scale of the Heisenberg uncertainty principle. With me so far?
Oh, yeah.
The thing is that because you've got this fuzzy space-time, it's very hard to work out how space-time is meant to curve, and in terms of gravity, when the things making it curve aren't exactly in one position. And you can do kind of tricky maths to try and nail down the, integrate across the different kind of points where the particles might be. But once you do that, you're getting down to these little points, and then the equations, you have to divide by 0. It goes infinite. The mass blows up, and yeah, you can't really combine general relativity and quantum mechanics very effectively from a mathematical point of view. It's something that Einstein himself searched for a way to unite them. Pretty much every physicist following Einstein has also sought a way to unite them. Now, Hawking himself did not actually, combine the two effectively, but he found a consequence of when you actually have both of them working together. So I mentioned those pairs of particles and antiparticles that pop in and out of appearance, like appearing and disappearing all around us. We call them virtual particles because they only kind of exist for a very short period of time. So they're happening all the time. All around us, these virtual particles are appearing and disappearing. But if this happens right near the event horizon of a black hole, then something different takes place. So now a black hole is something that is predicted by Einstein's theory of gravity. It's an object with a mass that's so large its gravity becomes strong enough that nothing can escape it, not even light. Okay? Which, of course, light being the fastest thing there is, and nothing can move faster than light. Now, the event horizon is kind of the point near the black hole where that gravity gets so strong that light can't escape. So it's kind of the point of no return in that sense. So anything inside the event horizon is lost forever. Anything just outside the event horizon has a chance of escaping if it's moving fast enough. Okay?
Right.
So if you have a pair of particle and antiparticle appearing just kind of on the edge, on the event horizon, one of them can fall in, and the other one then has no partner anymore to annihilate with, and so it just goes wandering off.
Right.
Now, some of them would get sucked in as well, but if they've got enough kind of energy and momentum, and they're far enough away, like if they've wandered far enough away, and their partner is gone, then they're left free to go away somewhere else. And there's enough of these happening, because it's happening all the time. There's nothing happening that you will actually, if you do the calculations, you'll see that the black hole is effectively giving off these particles. So it's actually losing energy and mass in the form of this radiation. If you were to wait long enough, or if your black hole was small enough, eventually it would evaporate.
Wow.
Yeah, it's kind of a big deal. It's a big deal because this is kind of a firm prediction of combining just standard level general relativity with standard quantum mechanics. So Hawking in doing this hasn't come up with a new theory of quantum gravity. He's just used the basic kind of things that we already know about how those theories work and combined them and come up with a prediction of something that would actually happen. A black hole would evaporate. Now, we haven't seen this happen because we haven't gotten close enough to a black hole to find out. But, it's a pretty firm prediction anyway. If it's wrong, then that would actually tell us something new about quantum gravity that we don't already know. As it stands at the moment, this is kind of like a pretty solid prediction. So that's Hawking's most famous achievement. It probably means more to physicists than to most people, but it's still pretty significant. He's done a lot of other work over the years. Hawking sometimes took controversial viewpoints, controversial in a scientific sense, I suppose, and he's sometimes been wrong. had a lot of bets over certain obscure properties of black holes and things that have turned out to be wrong.
And he had that birthday party as well, or that party for
time travelers.
Time travelers.
Yeah, when no one came back to him. He's actually trying to prove a point that time travel was impossible.
Yeah.
Because it was his idea that time travel was impossible. And so, anyway. But also, the thing is, his opinion is respected. This is one of the amazing things about him. He's such a well-regarded scientist that he can say these things, people will listen to him because, he uses influence wisely in that sense. Including when he commented on things that were outside his expertise, things like, artificial intelligence, he's talked a bit about in recent years, health funding, he got into kind of arguments with the government over health funding, and people listened to him and he always had something sensible to say, even if it wasn't always right, particularly in science stuff, he was always, gave a sensible answer, and then people listened to him. And I think this is one of the things that kind of inspires people, and scientists in particular, is to have a scientist who is kind of a public figure of respect. That's something that we can all aspire to, and I think that is that's a very rare achievement in the world, where scientists often feel like we're battling for the public attention. For someone who has achieved that level and is able to be that voice of science and have that level, then that's pretty impressive.
You are listening to Lost in Science, and as we were saying before, Stephen Hawking was probably one of the most famous physicists in history, would you say? Often spoken about in the same sense as people like Einstein and Newton.
He certainly played cards with them on Star Trek: The Next Generation.
Yeah.
And
he was sitting around a card table playing himself with two actors playing Newton and Einstein and upsetting Newton about making physics jokes that he wouldn't have been able to understand.
also playing with Commander Data.
Yeah. Also a great scientist of his own time, presumably.
Okay, anyway.
But he was also, he even was the subject of a biopic in 2014 starring Eddie Redmayne called The Theory of Everything, which is related to his actual physics work, but it was sort of more like it was sort of a dramatisation of his early life and focusing on the development of his motor neuron disease, which affected his family life and his career, obviously, as well. So motor neuron disease, the specific type that Stephen Hawking had was also known as ALS, which stands for amyotrophic lateral sclerosis. And it's basically a relatively poorly understood set of conditions.
Is this also the same as Lou Gehrig's disease?
They do talk about it as Lou Gehrig's disease, but there's actually a range of them, and this is one of the things. It's not one thing. It's sort of a condition. It's a group of conditions that results in specific degenerative problems that people have. So basically, what happens is that the motor neurons or nerves that control people's movement stop working. So they don't get the messages from the brain properly. So the signals being carried from the brain to the body get confused and the nerves stop functioning, and initially results in uncontrolled twitching and later develops into lack of control over the body, over the movement of the limbs and all the other parts of the body. So it makes walking and talking progressively more difficult, can affect breathing and swallowing, so it makes it hard for people to eat, but for some reason doesn't affect bladder or bowel control. So it doesn't affect all nerves equally, it only affects specific motor neurons. So it's, rather than being a single disease, as I said, it's a group of conditions. So there's no actual test for ALS. You can't just, give someone a blood test and go, well, you've got ALS. They have to actually diagnose it based on the progression of the symptoms over time, which, makes it difficult to actually diagnose for a start. But there also seems to be an early onset form of the condition and a version which affects people later in life. So most people get motor neuron disease when they're over 55, so they're actually quite old. Stephen Hawking was first diagnosed when he was 21. He's still at Oxford. So in the later onset form, the prognosis is usually that patients are expected to live for only 2 to 4 years after first developing the symptoms, and less than 10% of people live for longer than 10 years once they've been diagnosed. So it's pretty much a terminal condition. And often what happens is they develop breathing difficulties because the diaphragm is controlled by nerves. The nerves get the signals wrong, so people can't breathe, and they often develop pneumonia. So they have problems with their diaphragm and basically stop breathing. So Stephen Hawking was given an outlook of 2 to 4 years in 1963, and he lived for another 55 years with this condition.
So did he have that early onset form then? Perhaps?
Yeah, he did. And they actually kind of think that that's maybe part of the reason that he survived so long, was because there's a difference between the late onset and the early onset conditions themselves. But obviously he lost control of his voice, partly due to an actual operation. He had a tracheotomy at one point to keep him breathing, and then he couldn't speak. So then he had a computer voice, which he helped develop, that allowed him to communicate, which is pretty amazing in itself, really. But obviously, it's such an iconic voice. If everyone thinks of Stephen Hawking's voice, it's that computer voice, the robot voice.
That was like decades ago that he got that voice, and then I think they had more advanced versions, and he didn't want to change it because that was his voice. Yeah, everyone recognised.
Everyone knew who he was when you hear that voice. Yeah, he did continue his work, obviously in physics, despite his continuing health problems, and he actually believed that he got more work done as a result of his condition, because he was freed up from teaching and administrative duties at the university, which is what everyone else's time gets spent doing. So he kind of didn't have to do that stuff. So he got more time to do his own actual research, which is kind of funny in a way. He's also believed to be one of the longest lived patients who have had ALS. And they don't really understand why. And that's partly because they don't really understand what causes the condition in the first place. So they can't sort of pinpoint why he lived so long.
I was going to say ALS, that's the one that there was the ice bucket challenge for a few years ago, wasn't it?
Yes, it is.
And this is reflecting the lack of research. They had to have a silly internet stunt to try and get funding.
Yeah, that's absolutely true.
Silly, but
effective.
Did you do it?
No, I didn't. But I'm sure it raised a lot of money, right?
Yeah, certainly went viral.
Oh, look, it's better than planking.
Absolutely.
It's just planking with a cause, right?
Yeah.
But they have, some doctors have suggested that there are inherited genetic factors involved, but that's not exclusively a predictive thing either. So they can't necessarily say that just because you've got these genetics that it means you'll get ALS. They do suggest also that the early onset of his condition is a factor in him surviving so long, and that people who develop ALS later get affected much more quickly and destructively. So it comes on really fast, and it's no real way to slow it down. So obviously there's a lot of research around ALS seeking to find its cause and potential treatments for affected people. And as you mentioned, Chris, the Ice Bucket Challenge, which people might remember from a few years ago, probably the best known fundraising effort related. If people do want to find out more, they can go to the MND, that's the Motor Neuron Disease Australia website, find out how to be involved. They have a big focus on motor neuron disease in August every year. So hopefully the Ice Bucket Challenge will get a bit more publicity again this year.
You know, sometimes the news reads like a John le Carre novel. All secret conspiracies and spy thrillers. Well, this happened again this week when it was reported that a former Russian spy and his daughter were poisoned by a military-grade nerve agent developed in, of course, where would it have been developed in? Russia.
Was it developed in Russia or in the Soviet Union?
Well, I was just going to say, this does seem all a bit Cold War. I thought we'd sort of moved on beyond this kind of
I know,
activity.
right? I know. Putin's holding on to the past. Yeah, so it was developed in Russia, but even more so, it's highly likely that Russia was responsible for the attack. And yeah, it's left this former spy and his daughter in a critical state in hospital. Very, very sad.
So he's a former Russian spy, and
Yes.
they tried to assassinate him.
Yeah.
Nice guys.
Nice guys indeed. Anyway, conspiracies aside, it got me thinking about these modern day chemical weapons and that are the nerve gases. What are they, how they work, and what impact they have on the human body?
So I guess if you put it in those terms, aren't chemical weapons illegal internationally? Like, you're not really meant to go around using chemical weapons.
No, that is a different story for a different time. There are like treaties around the production and use of chemical weapons, specifically nerve gases, that mean that if Russia admitted to developing these, then they would be
In big trouble.
in big trouble.
Yeah.
Yeah, but you know, maybe they don't care about what the UN says. I don't think they do.
Please don't if you're listening. This is Claire's story.
Anyway, so the chemical used in the attack has been identified as one of a group of nerve agents known as Novichok, which in Russian means newcomer. It's reportedly 5 to 8 times more toxic than sarin or the VX, I think it is pronounced, VX nerve agent. And it's also harder to identify than those ones. You might remember VX from last year's weird newspaper stories about Kim Jong-un's half-brother being murdered.
In a Malaysian airport.
In a
it's not
Malaysian
that-
airport, yeah. So that VX was the nerve gas that killed him. So
And sarin was the one from the Tokyo subway attacks back in the 90s, wasn't it?
that's right. So Novichok, or newcomer, can come in many forms. It can come in liquids. It's thought to exist in solid form and can also be dispersed as an ultrafine powder. But some of these agents, in particular Novichok, are reported to be binary weapons. So it can be stored as 2 less toxic chemical ingredients and then mixed on the go into a more active toxic agent, so it's easier to transport.
Like araldite.
Yeah, I guess like extremely dangerous araldite.
Okay.
Yep. It takes effect really quickly. So if a person inhales it, or even if it touches the skin, it begins to take effect, and symptoms can be seen 30 seconds to 2 minutes afterwards. However, in powder form, it takes longer to act. So it can be up to 18 hours after exposure when it's in its powder form. So this stuff is some of the most dangerous weaponry around. In fact, an academic from ANU said that after the atom bomb, nerve agents are possibly some of the most dangerous things that humans have ever made. And I can sort of believe it. But what they actually are a group of chemicals that generally all work in the same way. And that way is to mess with nerve junctions or synapses. So there's an enzyme that's present at nerve junctions, and it's called acetylcholinesterase.
That name again?
Acetylcholinesterase. Or for ease of listening, dear listeners, let's just call it ACHAs. Now, under normal circumstances, the enzyme ACHAs tightly controls the amount of a neurotransmitter called ACH. So it controls this neurotransmitter ACH crossing this nerve junction or synapse, and it does this by breaking down the ACH. Now, ACH has a very vital role in the human body, specifically in autonomic nerve function and the nervous system. So things we do automatically, like specifically heart rate, respiratory rate, salivation, digestion, pupil dilation, and urination. But the enzyme, this ACHAs, effectively works as an off switch. So we don't overstimulate the automatic nervous system. Now, then this Novichok, the nerve gas, or this nerve agent, comes along and it actually inhibits or stops the enzyme working. So this ACHAs stops working. So there's no enzyme keeping the neurotransmitter in check, which means your body has one less off switch. Or as some people describe it, all the lights in your body are switched to on, and there's no way to turn them off. And your body starts running into trouble after that. So the ACH neurotransmitter starts building up in the synapses more and more, and things like secretions, respiratory problems, muscular dysfunction starts happening pretty quickly after this.
So basically your whole body just goes into overdrive by the sound of things.
Yeah.
It just starts doing all of its jobs all at once.
Does all of its jobs all at once, and then it's just a matter of time until you become comatose, which is what happened to the people who were exposed to the Novichok. I'm probably saying that incorrectly. If anyone is Russian, can you please correct me how to say that?
Oh, they'll be correcting you, Claire.
Yeah. Anyway, you might have heard of neurodisruptors or like chemicals that are neurodisruptors like this. Organophosphate pesticides are nerve disruptors used in agriculture. They're designed to attack the nervous system of agricultural pests, of course, so invertebrates, not humans. That said, human exposure to organophosphates is very dangerous and kills people every year. So, this is a timely reminder that even though we are living in somewhat peaceful times, there are some of the most dangerous tools of death and destruction still out there in the world.
That's all we've got time for on this episode of Lost in Science. Thanks for tuning in and joining us. Lost in Science is recorded at the studios of 3CR in Melbourne and broadcast across Australia on the Community Radio Network with the financial assistance of the Community Broadcasting Foundation. If you want to talk to us, talk back to us, you can get in touch. We have a Gmail account, lostinsight@gmail. You can also find us on Twitter and on the Facebook. And if that's not enough Lost in Science for you, you can always tune in again next week where the team will once again get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.